Diameter. So, if someone asks you what the definition of the diameter is, it is the longest chord on the circle and it passes through the center. I'm telling you this to disavow yourself of the notion that diameter is different than circle. Fundamentally, it's the same thing. A diameter is a chord, but is every chord a diameter?
No.
No. The only way that a chord can be a diameter is if the chord does what?
Pass through the center.
Pass through the center of the circle. Good. All right. The radius is the common distance between the center and all the points on the circle, right? Measure from any point on the circle to the center, and I will get the same distance. That distance is the radius. Good. All right. The tangent makes a very interesting little thing here because the tangent ends up touching the circle at one point. What is even more fascinating about it is, were you to take a segment from this point of tangency to the center, those two lines would be perpendicular to each other. They make a 90-degree angle all the time. And the way you construct one, as I'll bring that up, the way you construct a tangent in Sketchpad is actually pretty easy. I'll show you that as this warms up. Okay? Now, last week, explain to me what I did with this.
You just drew the one around.
I made this the length of the diameter, right? I made this the length of the diameter of a circle, and then I figured out how many diameters went around the circle. What did we find? A little bit more than 3 diameters go around the circle. I don't care what size circle it is. Take a piece of string that's the diameter and go around the circle. It will go. I don't know. Oh, I know why, because I was. New sketch. If you wish to build, where are my tools? All right. If I were to draw a circle and put a point on the circle, how would I find the tangent line? Simple. I make a radius and I do a perpendicular line at this point perpendicular to this. I have a tangent. No matter how I draw it, I have a tangent. The circle touches once and only once. See that? Now, forgetting this for a moment, hide this bad boy. And in fact, hide the center. How do we find the center of a circle? We use the notion of the chord. If I take a chord, find its midpoint, and build a perpendicular through that chord, at that point, the circle must lie somewhere on that line.
You mean the center?
What's that?
You mean the center?
Yeah, the center, I mean. The center must lie somewhere on this line. So in order to triangulate where it is, I'll just build another chord. It doesn't matter how long it is. Find its midpoint.
What'd you do?
Find its midpoint. Do a perpendicular. Wrong tool. Do a perpendicular here. So what's that going to do? It's going to say that the center lies on that point. The intersection of the two lines is the center of the circle. And to show you that, picture where it is, and now I'm going to show all hidden. Show all hidden. See the center? Okay? So, by the way, if this was 8, this would be 8, right? What's this angle? 90 degrees. 90, 90, 99. Okay? The idea. Phenomenal. Okay. So, enough with this for the rest of the period. So now, someone asks you, tell me what pi is, and inevitably most people would say 3.14159, but we learned last week, 8th graders, that it is not that. It is,
Apples.
It's circumference divided by denominator,
Yes.
which is why you said a little more than 3, which is 3.14.
that's right. Pi is the ratio of the circumference to the diameter of any circle. I showed that last week by taking a diameter and taping it around the circle. And we found that a little bit more than 3, but a lot less than 4 diameters fit around the circle. You have been taught that pi is 3.14. That is an approximation. You have been taught that a more accurate estimate is 3.14159. All right? The more number of decimal points you get, the better the approximation. Unfortunately, I don't care how many decimal points you give me, it will never be exactly pi. Why?
Because it goes on forever.
It goes on forever, without repeating, without terminating. It is an irrational number, not rational number, right? So here's the thing. On the SAT, they don't want you to use 3.14. They want you to write the pi symbol, and here's why. Pi is exactly equal to the circumference divided by the diameter. 3.14 is approximately equal to the circumference divided by the diameter. To be exactly correct, you need the pi symbol. Okay? So if I tell you that the diameter of a circle is 2, the circumference is approximately equal to 2 times 3.14, or approximately equal to 6.28. However, if the diameter is 2, the circumference is exactly equal to the pi symbol times the diameter, which is 2 pi. That's exact. This is an estimate. So, we keep the pi, and we make our lives much, much easier.
Pi makes lives.
So we keep the pi symbol. All right? With that in mind, last week we did this. Radius, diameter, circumference. And we figured out that there are only 3 possible problems that I can give you with radius, circumference, and diameter. Specifically, if I give you this, can you find the other 2?
Yes.
What's the circumference?
5 centimeters.
10 pi centimeters. Pi times diameter.
And the radius?
Right? Done. What's the radius?
5 centimeters.
5 centimeters. What if I gave you the radius? 8 centimeters. 16 centimeters.
16 pi.
16 pi centimeters. Yes. And what if I gave you this? 22 pi centimeters.
11.
11 for where?
Radius.
Radius. And 22 centimeters for the diameter. Doing circle problems is a fluency thing at your age. It should be anyway, as long as you use the pi symbol.
Why is it 2 pi r? Like,
Good question. Excellent question. You've been taught that circumference is 2 pi r. Does anybody want to answer that who was here last week? Arlen? Okay. Thomas?
Anyway, you could also rearrange the multiplication in 2r times pi, and 2r is equal to the circumference.
To the diameter.
Sorry,
See it?
yeah, but my question, I was here, but my question was like, why did they put it like that? Like, why didn't they just do pi?
Here's why. 2 is a number, pi is a number, even though it doesn't look like one. The radius is variable, right? And when you're taught how to write a number times a variable, like 2 times x, you don't write it x2, you write it 2x. Therefore, you put all the numbers ahead of the variable. And since pi is a number, and I never think of it that way, I think of it as 2 radiuses times pi. You see what I mean? And all we're doing is using the associative property. 3 numbers multiplied together, doesn't matter what order you put them in. Make sense? Okay? So now, we get into the notion of area. Now, they will teach you two formulas for area. They will teach you that the area is equal to pi r squared. Some of you may even have seen this formula. And then you wonder, where in God's name did that come from?
It's the same thing as r squared.
It is, because when you take the radius is diameter over 2 squared, isn't it? The radius is diameter over 2, and what happens? D squared over 2 squared. I hate this formula. Don't bother memorizing it. It's crap.
Crap. Do that again. Do that again.
It's crap. Anybody ever seen Caddyshack?
No.
What are you doing? You need to move the hose. All right. Or that bastard from Austin Powers. Ever
Oh.
seen him? He's got a Scottish accent. All right, now, guys, what's the area of this circle?
Pi 5 squared.
5 squared, 25 pi. Done, right? Next question, what's the area of this? 64 pi. Area.
121.
And what if I give you this?
So what? What?
Come on. You guys should know this.
That's like 16 something.
Wait, which one is it?
I'm giving you the area 324 pi.
Pi.
This is where fluency comes in. 324 is a number that I taught you. 18. 18 squared is 324. So you should be able to say that the radius is 18. You see that? The square root of 324. So you do this, you do the radius by doing the square root of 324. And by the way, on the SAT, they will be all whole numbers. They will all be from 1 to 20. That's